This is Algebra 1, Lesson 4.2, Graph and Linear Equations, the beginning of Graph and Linear Equations. We're using tables or a list of values, which you'll notice to be very similar to each other, to graph lines, and we're going to graph horizontal and vertical lines beginning on page 210. Two definitions to start. One of them is the solution of an equation. What you have to know about a solution of an equation is that it's going to make a true statement when you plug it in. So you're going to get an x and a y value, and when you plug them in, it's going to give you a true statement. We have evaluated truth value on equations so far. We're doing the same thing with this. A solution of an equation will be true. The graph of an equation is the picture, just like the graph of a point, like we learned earlier this week. The graph is not this right here. The graph is the point that you actually put in. It's the same thing with the graph of an equation. The graph is the actual equation itself. Notice there's going to be an arrow going in each direction, which tells you that it infinitely goes forever, and it shows you forever going this direction and forever going this direction, and every point in between. Example number 1 says verifying solutions of an equation. All we're doing right here is checking the truth value. Now you can do it two different ways. You can do it without ever looking at the picture out over here on the right, because sometimes the pictures won't be drawn very well for you. Sometimes you'll see the little phrasing out to the right. It'll say like picture is not drawn to scale or something like that, and it might not look like it fits. All you have to do is plug the values in. This one being x and this one being y. If you get a true statement, then it's going to be a solution. Or you can just find that point 3, -4, like 1, 2, 3, -1, 2, 3, 4. That falls right there. It falls on the equation. Don't think about the little circle I drew, but it falls on the graph of the equation, which means it is true. -4, +3, -1, 2, 3, 4, +1, 2, 3. That does not fall on the line itself. It does not fall on the equation, so it won't be a true statement. So the point is on the graph, therefore 3, -4 is a solution. You can check it algebraically. So when you plug the values in, again, you plug it in x's value is 3, and you plug it in y's value is -4. 2 times 3 is 6. 3 times -4 is -12. 6 minus 12 is going to be -6. That's a true statement. We know that's true. Again, this is the only way we've done it in the past. We've just seen if it's true. Now we're giving you another way to check. The other one, -4, 1, again, when you go -4 to the left and +1, I don't know why I went up 3 a minute ago, +1, notice it's above the line. It's close, but it doesn't fall on the line itself. Therefore, it's not a solution. Again, you could check it algebraically when you plug it in. -4 in place of x, y in place of 1, or 1 in place of y. 2 times -4 is -8. 3 times 1 is 3. -8 plus 3 is going to be -5. That is not a true statement. So it is not a solution. Again, two different ways. Both ways of checking the equation are correct, either by seeing if it's on the graph or by plugging it in to see if it gives you a true statement. Okay, take 1 minute and do both of these. Determine either way. I'll take 30 seconds. It'll be even faster. Determine with either method if they are solutions of the equation. Here's the equation here. 4x plus y is equal to 8. And there's the picture of it. Okay, that ought to be long enough. If you did it using the picture, you probably went a whole lot faster than plugging it in. So we'll use both methods again just to make sure, give people options. The first one, 1, 4, A. Remember, x comes first. That's always first. So 1 and then 1, 2, 3, 4. That's where your point is. It's on the line. That is a solution. The other one, when you plug it in, that's A there. The other one, when you plug it in, 3, 4, when you go 1, 2, 3, 1, 2, 3, 4, falls right there. That is not a solution because it does not fall on the equation. If you plug the values in, you plugged in 1 in place of x for the first one, 4 in place of y, for the first one. 1 times 4 is 4, plus 4 is going to be 8. That's a true statement. If you plug in the second one, 4 times 3 is 12, plus 4 is 16. That's not equal to 8. So checking it both algebraically and using the picture itself. Okay, and then you have 3 steps to graphing a linear equation. The first one is to rewrite the equation in function form if necessary. All this means is make it say y equals something on the right. That's what function form means. The better function form, or the best one, the most useful one we'll use in here is slope-intercept form. You'll make it say y equals mx plus b. But again, function form, all it means is y equals. Get y by itself. But slope-intercept form, mx plus b will be the most useful one. The second one is choose a few values of x and make a table of values. Copy these numbers down right now above this box. -2, -1, 0, 1, and 2. You never have to choose any numbers outside of those 5 numbers. Some of y'all are thinking, well, I don't want to use none of the negatives. I understand that, but you're going to have to use negatives sometimes. These are the easiest numbers to mentally do calculations in your head with. Everybody in here knows that they can multiply by 0. It's real easy. Everybody knows they can multiply by 1 and -1 conversely, real easy. 2's the hardest one up there because you got to double things sometimes. Okay? But -2, again, it's real small numbers. It makes it easier to work in your head. It says choose a few values. That means choose 3 of them. So if all you have to choose is 3, pick those 3. Those are the easiest 3. Sometimes you're going to need to use 5, though, and that's when you extend to -2 and +2. Those are going to be the easiest numbers almost all of the time. There'll be some examples I'll show you every now and then where it'll be easier to use another number, mostly because of fractions. Then the last one is to plot the points from the table of values. A line through these points is the graph of the equation, or it's the line. So all you do is you use those values. This is going to be your x values. X is -2, -1, 0, 1, and 2. You make what's called an input-output machine. We've seen things that look like that already. We're going to see more today. Okay, here's example number 2, graphing an equation. X plus 4y is equal to 4. First thing you got to do is rewrite it in function form, or get y by itself. After an equation is rewritten in function form, it's easier to make a table of values. So that's the reason why you do it. So what you want to do is you want to move over this positive x. We did it on the bell work. We had 2 of them just like this on the bell work. It's positive x. When you move it over, it becomes negative x. So subtract it. When you subtract it on the left, you got to do it on the right. Notice it becomes negative x. And notice they wrote negative x before the +4 to make it say mx plus b. It still doesn't say y by itself. You have to divide by 4 on both sides. When you divide by 4, -1 times x, when you divide it by 4, it becomes -1 over 4 times x. So you're just dividing the -1 before you divide the x. And then 4 divided by 4 gives you 1. This is y equals mx plus b. Choose a few values. Notice what it chose, 2, 1, and 0. I'm sorry, it chose -4, 0, and 4. I don't know why it used these values. Let's just go along with it for right now. In fact, I do know why. It's because of the fraction itself. 4 is easier to multiply by than 1 when you're multiplying by -1/4. So when you plug those values in, it's just like saying y equals -1 over 4 times -4 plus 1. That's just plugging in that value of x. A negative times a negative is a positive. 4 divided by 4 is 1. So what you get is y, when you put those two together, equals 1 plus 1, and that's where you get the number 2. When you plug in +4, or when you plug in 1, I'm sorry, you get -1/4 times 1 is on the other one, y equals -1/4 times 0 is the next number it plugs in. So anything times 0 is 0, plus 1 gives you 1. And then when they plug in the number 4, +4 this time, -1/4 times +4 is going to be -1, not +1 this time. And then when you add it back to the number 1, you get 0. So this is your input-output machine we made. We made we made three different ordered pairs. One of them is negative 4, 2. When you graph negative 4, 2, it's going to be at negative 4, positive 2. When you graph 0, 1, it's going to be at 0, 1. And when you graph 4, 0, it's going to be right there. When you have 3 points, you can draw yourself a line through the 3 points. Okay, checkpoint number 1 says use a table of values to graph the equation x minus 2y equals 1. Table of values, let's make it real short. X comma y, negative 1, 0, and 1. Real simple. So when I plug them in place of x, it's the x values, you plug in them right there. Negative 1 minus 2y equals 1. The first thing you want to do, though, is you want to make that equation into y equals mx plus b. X minus 2y equals 1. Move x over, just like on the bell work, by subtracting it. Now you have negative 2y equals negative x plus 1. Get rid of negative 2 times something by dividing by negative 2. Divide it here and here. So y equals a negative divided by negative is going to be a positive 1 over 2x. And a positive divided by negative is going to be a negative 1/2. So when we plug these values in, negative 1 and 1, what we're going to get, 1/2 times negative 1 is going to be negative 1/2. And this is an instance where I told you it's always going to be easy to use numbers 1 and 0. This is an instance where it'll be easy to use the number negative 2 and positive 2. Because when you plug them into 1/2, you're going to get the number 1. So 1/2 times negative 2 is negative 1. And negative 1 minus 1/2 is going to be negative 1.5. And all we're doing is working the equation. When you plug it in again, this is your form. When you plug it in again, when you plug in 0 times 1/2, you get 0 minus 1/2, you're going to get negative 1/2. And then when you plug in 2 times 1/2, you get 1. 1 minus 1/2 is positive 1/2. So then you graph those 3 points, and I know it's graphed already for you. At negative 2, negative 1.5 is going to be 1 point. At 0, negative 1/2 is going to be your second point. And at 2, positive 1/2 is your third point. When you have the 3 points, you can graph a straight line through all 3 of them. Okay, and then we have horizontal and vertical lines. If y equals b, so now it says y equals some number. Let's say this number is 2. Then y's value, this is your y-axis, is going to be at 2. It's going to be at 2 here, and it's going to be at 2 here. It's going to be at 2 the whole way. So it's going to be a horizontal line. The same thing with x values. If this one right here is x equals negative 1, it's going to be negative 1 on your x-axis. It'll be negative 1 here and there as well. It gives you a vertical line. Then you have 2 examples. The first one, y equals b, makes a horizontal line. Notice all of your y values are negative 3 when you plug in some values. It just used the values negative 3, 0, and 3. But y's value is negative 3. So this is your y-axis. At negative 3, at 3 it's negative 3, and at negative 3 it's negative 3. So it makes a horizontal line. And the same thing's true with x equals a. X is going to be a vertical line. In this case, x's value for all of them is the number 2 when you plug in different values for y. So again, this is your x-axis. On that, it's going to be 2. It'll be 2 here, and it'll be 2 down here as well, which creates a vertical line.